me and my partner will explain about the bond interpretations. This is the wave function. It cannot represent the density of the particle or charge density of the particle, but it represents the probability of finding particle in the point or a moment. Okay, next, the wave function symbol is called psi. Psi have a finite region and finite value, and that is called wave pattern. We can describe it in this equation. The mod psi square equal to psi into the psi star. This is the wave function symbol, and the psi star means that the imaginary wave function. Whenever mod psi square equal to 0, it means that it indicates the minimum probability, and if the mod psi square equal to 1, it indicates the maximum probability. And that is based on this equation. The first one is the one-dimensional normalized equations. The second one is the two-dimensional normalized equations, and the third one is the third-dimensional normalized equations. There are several of the importance of the wave function. The wave function completely defines the system like electron in an atom or the molecule. And if we know the wave function, we can determine any observable property like energy, vibrational frequencies of the system. And the quantum mechanics provides the tools to determine the wave function, and to interpret, to use the wave function to determine the property of the system.
My name is Siti Nuraisyah binti Kamarulzaman, and I will present about the bond interpretation. Okay, the bonds was developed by the Max Born in 1926 paper. Max Born solved the Schrödinger equation for scattering problem, and inspired by the Albert Einstein and Einstein probabilistic rule for photoelectric effect. Okay. Max Born also formulating the first mathematically precise statement for the first law of thermodynamics. Max Born, who is a German physician, developed a law of quantum mechanics which gives the probability of a measurement of a quantum system yielding a given result, since called Born rule. Okay. The Max Born was awarded the Nobel Prize in Physics in 1954 alongside with the Walter Bohr. Max Born was awarded for his fundamental research in quantum mechanics, especially for his statistical interpretation of the wave function. The wave function contains all the dynamic information about the system. Born made an analogy with the wave theory of light. Square of amplitude is interpreted as intensity, finding probability of photon. Okay. Probability to find a particle is proportional to the probability intensity. Okay. It is okay to have negative value for wave function. As you can see in this figure, the sign of wave function has no direct physical significance. The positive and negative region of this wave function both correspond to the same probability distribution as given by the square modulus of wave function and depicted by the density of shading. For your information, there's a few limitations on the wave function. Okay, the first is wave function must be finite for all values x, y, and z. wave function must be single value. Example, for each set of values xy and zy must have only one values. Okay. The third limitation is wave function must be continuous in all regions except where potential energy is infinite. Okay. The fourth is wave function is analytical. For example, it possesses continuous first order derivative. And last but not least, the limitation of the wave function is wave function vanish at the boundaries.